pause for a second. Look at your hand. Now imagine shrinking yourself down until that hand is smaller than an atom. Keep going. Smaller. Smaller still. By the time you stop, you'd be smaller than anything science can measure. And you still wouldn't be small enough. Because compared to the universe, you're not just small. You're beyond small. You're statistically irrelevant. And yet, here you are, asking the question, how big is the universe? Let's find out. But fair warning, you might feel different by the end. Let's start where you are. Earth, 12,700 kilometers wide. It takes a commercial airliner about 2 full days to circle it without stopping. Oceans, mountains, continents, all of human history happening on this spinning rock. But Earth is just a pit stop on a much bigger road. The moon orbits 384,000 kilometers away. If you drove there at highway speed, nonstop, it would take 5.5 months. And the moon? It's basically our backyard. The sun is 150 million kilometers further out. That light warming your face left the sun 8 minutes ago. If the sun suddenly vanished, we wouldn't know for 8 whole minutes. The Earth would keep spinning, clueless, until darkness hit. Mars is next. At its closest, 55 million kilometers away. Our rovers have been crawling around up there for years, sending back selfies from a world we'll probably never visit in person. But Mars is still in our neighborhood. Further out, Jupiter, big enough to swallow 1,300 Earths. Then Saturn with its rings, Uranus on its side, and Neptune at the edge. Neptune is so far that sunlight takes 4 hours to reach it. 4 hours. For light. But here's the thing. Even Neptune isn't the edge. Wrapped around our entire solar system is something called the Oort Cloud, a shell of icy debris, trillions of objects, stretching nearly a light year from the sun. A light year. That's the distance light travels in 1 year. About 9.5 trillion kilometers. To reach the edge of the Oort Cloud, light itself takes nearly a year. And we haven't even left the solar system yet. Numbers this big stop making sense. So let's shrink things down. Imagine our entire solar system, from the sun to Neptune, is now the size of a US quarter. A tiny coin in your palm. At this scale, how big do you think the Milky Way galaxy would be? The size of a house? A city block? Try the entire United States. From New York to Los Angeles. That's how much bigger our galaxy is than just our little solar system. The Milky Way contains 400 billion stars. If each star were a grain of sand, you could fill every beach on Earth, and then some, and still not count them all. Our sun is just one grain in that endless desert. And some of those grains are terrifyingly huge. There's a star called JWST. If it replaced our sun, its outer edge would reach past Jupiter. Earth would be swallowed instantly. You could fit 5 billion suns inside it. Then there's Stephenson 2-18. Even bigger. It would take 9 hours to travel around it at the speed of light. Around our sun? 15 seconds. That star could hold 10 billion of our suns. 10 billion. And yet, all of these stars, billions of them, are just tiny sparks in the Milky Way. Our galaxy is 100,000 light years across. To cross it at the speed of light, you'd need 100,000 years. Human civilization has only existed for 6,000. But the Milky Way isn't alone. Hanging out nearby is Andromeda, our largest galactic neighbor, 2.5 million light years away. And it's coming straight for us. In about 4.5 billion years, the Milky Way and Andromeda will collide. But here's the beautiful part. They won't smash into each other. The distances between stars are so vast that galaxies just pass through each other like ghosts. Andromeda and the Milky Way are part of something called the local group. About 54 galaxies, all bound together, spanning 10 million light years. If the Milky Way was a grain of sand, the local group would be, well, still incomprehensibly huge. But wait, the local group is just one tiny piece of an even bigger structure. The Virgo supercluster, a collection of at least 100 galaxy groups and clusters, stretching 110 million light years across. Inside the Virgo supercluster is a galaxy called IC 1101. It's the biggest one we've found. It could fit 1,000 Milky Ways inside it. 1,000. And at its core sits a black hole so massive, it's in a category of its own, an overmassive black hole. Speaking of black holes, there's one called TON 618. 66 billion times heavier than our sun. Its shadow alone is bigger than our entire solar system. If it replaced the sun, we wouldn't even see light. We'd just feel ourselves getting stretched into spaghetti. And here's the mind-bender. TON 618 is so far away, 18 billion light-years, that we're seeing it as it existed before Earth even formed. We're looking at a ghost. But even the Virgo supercluster isn't the top of the chain. It's part of something called Laniakea. In Hawaiian, it means immeasurable heaven. And it lives up to the name. Laniakea spans 520 million light-years. It contains 100,000 galaxies. Its mass is equivalent to 100 million billion suns. And at its heart lies something we can't even see, the Great Attractor. The Great Attractor is a gravitational anomaly so powerful that it's dragging our entire galaxy, and hundreds of others, toward it at 2 million kilometers per hour. We're moving right now, faster than any human-made object, towards something we can't even observe. But Laniakea itself is just a thread in an even larger tapestry. The cosmic web. Filaments of galaxies stretching across billions of light-years, connected like neural networks. And between them, voids. Empty bubbles where almost nothing exists. One of those filaments is called the Hercules, Corona Borealis, Great Wall. It's 10 billion light-years long. That's 10% of the entire observable universe. One single structure. And it's so huge that it shouldn't exist according to our models. Scientists have no idea how something that big formed so quickly after the Big Bang. Either our models are wrong, or the universe is even stranger than we thought. Which brings us to the observable universe. Everything we can see. Every galaxy, every star, every black hole. All of it fits inside a sphere 93 billion light-years across. But here's the catch. Observable doesn't mean everything that exists. It just means everything whose light has had time to reach us since the Big Bang. Beyond that, there could be more universe. Infinitely more. Scientists estimate that the total universe, if it's finite, could be at least 250 times larger than what we can see. That's 7 trillion light-years across. 7 trillion. And that's the conservative guess. Let's shrink things one last time. Imagine the Milky Way is now a single grain of sand. Just one. At that scale, the observable universe would be taller than the Burj Khalifa, the world's tallest building. A grain of sand next to a skyscraper. And that's just what we can see. The actual universe could be infinite. Endless. Going on forever in every direction. Galaxies upon galaxies upon galaxies, stretching into eternity. Think about that. If the universe is infinite, then somewhere out there, there's another version of you reading these same words. And another. And another. An endless sea of copies, living slightly different lives. Here's the most haunting part. The universe isn't just big, it's getting bigger. Expanding faster and faster. Galaxies beyond our local group are accelerating away from us. One day, they'll move faster than light. Trillions of years from now, any civilization born in that distant future will look up and see nothing but darkness. They'll have no idea the universe was ever bigger than their own galaxy. All that knowledge, lost forever. They'll never know about the cosmic web, the superclusters, the billions of galaxies. Because the light from those galaxies can never reach them. The universe will have erased its own history. So when we ask, how big is the universe? The answer is both beautiful and terrifying. It's bigger than we can imagine, bigger than we can measure, maybe bigger than infinity itself. But the most incredible part, we're here, we're conscious, we're asking the question. In all that vastness, in all that endless dark, something happened. We happened. The universe may be infinite, but it produced us, and that means we matter. This is Cosmic Pulse. Keep looking up.